tires fit around the wheels to cushion the ride. It's actually the wheels that bolt to the axle of the car and turn to make the car go. The wheels have to be light enough for the car to perform well and get good gas mileage, but also strong enough to support the full weight of the car, which can be 4,000 pounds or more. The wheel cannot fail because the safety of the whole car and everyone in it is riding on it. To make the wheels as strong as possible, each one is machined from a single piece of aluminum. That way, there are no parts to come loose or break. It takes a carbide blade to cut the raw aluminum stock into 30-pound billets. Each billet makes one wheel, with 20 billets cut from each bar. The billets travel through an oven for 2 hours until they're heated to over 900 degrees Fahrenheit. This softens the aluminum for forging without melting it. A rotary forge machine takes the soft billet and presses it into a thin disc using 4,000 tons of pressure. The heat from the furnace, along with the incredible pressure, not only reshapes the aluminum, it rearranges the molecules into a tight circular pattern. This new molecular arrangement gives the wheel its strength and durability. When the disc is cooled to room temperature, it travels to the cold forming machine. The disc sits on a mandrel. Then, giant rollers drop down, and like a potter's wheel, the rollers mold and stretch the aluminum into a wheel. A coolant cuts down on the friction, but blocks the process from view. We asked them to run the machine without coolant for a minute, so we could see how it shapes and stretches the metal. The aluminum goes from flat disc to a wheel that's 18 inches tall in just 45 seconds. A rack hoists the wheels up into a furnace that heats them to 985 degrees. Once again, the aluminum is not melted. It's only heated or tempered to even out and further strengthen the molecular structure in the aluminum. A tank of cold water rolls into place under the furnace to immediately quench the wheels as they emerge. This literally freezes the new denser molecular structure in place, locking in the strength. A computer-controlled lathe carves out the rims and other contours of the wheel. A smaller mill carves out a spoke-like design, which is part style and part function. In addition to giving the wheels a sporty look, the openings help circulate air and cool the brakes. The mill cuts away more material to create holes for the lug nuts that hold the wheel to the axle. The finished wheel is carefully inspected to make sure it's perfectly round. A dial takes measurements at various angles around the wheel. If it's not perfect, the tire could wear out faster in certain spots, creating a safety hazard. If the wheel passes, buffers move in to polish the aluminum to a bright shine. The wheels then ride on a carousel that dips them into washing tanks. and the brand new wheels are ready to hit the road. The number 10 business envelope, as it's called, is one of the most widely used envelopes